welcome to my channel. Um, Today, as I explained a week ago, I'm going to introduce yourself to buffer overflow. Um, what is buffer overflow? It's a kind of attack that reproduce a problem on your or execute a vulnerability on your own laptop. An attacker could redirect the flow of the executing process on your operating system in order to make the instruction that nobody wants. Okay. Um, in order to introduce yourself to this attack, I'm going to explain so quickly a little bit of what happened on the servers and laptop when a process is executed. Okay, let me explain. This could be a PC. Okay. There are three or four um, hardware pieces of the laptop that we need to understand how to work. For example, we have the CPU. Okay. We have three different kinds of memory. For example, this is the hard disk. This is the memory one. This is the most higher memory, but the most slower. No. We have the RAM memory is RAM memory, and the RAM memory, it's a little bit more bigger than the cache memory. Okay. The most bigger is the most slower. The medium memory, it's more faster, but it's slowest than the cache memory. Usually, all the process on the operating system they are executed in the RAM memory. Yeah. The usual documents, all the things are stored in the hard disk. Okay, in that case, on buffer overflow attack, we need buffer overflow. We need to understand how to work the different process, proc 1, proc 2, 3. Okay, there are okay. Okay, another one process. Okay, when some program is executed on the operating system, like this, with this program I wreck the video, is executed on the RAM memory and it's stored in the init of the operating system on the hard disk. The cache memory is used usually for the most faster operations um, that the operations that usually is executed for faster. How to can explain that? How can I explain that in English? For example, when an instruction is executed during a loop, is stored on this cache because the CPU get the content more faster than if this instruction is stored on the RAM or on the hard disk. There are another kind of memory that is virtual memory that usually execute on Linux environments, that is the swap. Okay, when this RAM memory is full, usually the operative system, in order to continue execution, write here some content, but it's so slowly, and we don't need to explain anything about this. Okay. Okay. Um, in that case, all the program and process is executed on the RAM memory. If we execute at top, we can check all the process executing on the operative system, and if we press M, this is the stored memory on the operating system. There are the CPUs on my computer. Okay. Especially on Linux machine and CD proc, there are the process that it's executed on the operating system. This is the PID of a number of process. Yeah. Why I explain that? Because when some program that or process that is a program in execution, okay, is working, the content of the memory is stored on this RAM, and you can try to, or you could try to find vulnerability in order to inject your own instruction and execute directly the functions here on the register of the CPU. Okay, exec instructions. Okay. This is the entry of the buffer overflow attack. It's when some program ask a user for an input entry, you can try to overwrite the stack on the reserved memory for the process, and try to inject some instructions for get the control of the EAP registry. That is the most important registry because control the next instruction to execute by the operative system. For example, if we open this debugger and we attach some process, yeah, we can check the registries here. These registers, there are the control of the CPU. Okay, the CPU get the registers and make instructions It's the higher way for the humans to understand the process or the control of the hardware, no? Because it's assembler instructions. Okay. Um, anyway, I'm going to show you how to work this program. This is the main content on the program. Okay, main program that execute a function that say do something, and this function execute only one instruction, that is string copy. The string copy copy the content of buffer, the input value, on my bar. Okay, what happened with that? Okay, if the input value are 1, that entry by the input entry of the program has more side than the reserved for my bar, you can override the side stored or allow it for my bar, and in that case you can or you could override or overflow the stack. Okay, how it's work this? If you have in a process the content of my bar, my bar, yeah, that has a size of 128 bytes, yeah, and your input value, your buffer, has, for example, buffer 228. When you try to copy this content, there are another instruction on the stack that you are overriding. All this content is new. You are override the stack memory of the process. Yep. If we know how to do it, we can get, or we can override the right bytes in order to control the flow of the program. How to do it? I'm going to show you how to make an exploit for control the flow process of this program. If we open CDC exercise test 1, yeah, we can exec stack buff exe, say hi, hello. No, this is Windows. Sorry. you can entry hi, hello, yeah, and when the program execute, write an output that say done. Okay, because all were right. If we execute the same program with a higher value of 128 bytes of size, for example this entry, we are going to get an error. Okay, and say, oh, we have a problem. Windows, close the program, close the message. Okay, and this is the stack buff error. Yeah, don't send. I don't remember if the operative system is not right configured. It's possible that system remote configuration prevention stack buff, apply, okay, accept. Okay, we are going to restart the machine because deep in Windows it's a control prevention of byte execution on the register directly. It's a control that Windows introduced, but by default is configured only for the functions or the programs that belong to the operative system scope in the user's desktop. For example, from the servers, Windows Server, execute for all process. But anyway, we are going to exploit this program, PC C exercise test 1. Yeah, and this is the exploit, the initial exploit. Okay, this is finally the exploit that we are going to execute. cdc exercise test 1. If we perform Python I don't know, stack pay exploit is Python, sorry, stack pay, yeah. Yeah, we perform follow, yeah. Execute a calculator. This is a one shell code that we introduce. Okay, we can close that and close that. We are going to exploit step by step the buffer overflow. Okay, this is the streaming buff pay. Okay, any file, save. Okay, print init buffer overflow. Okay, we can check the execution, Python, streaming buff, yeah, init exploit of buffer overflow. Okay, important things. With such process, we can execute some programs on the operative system. The debugger CMD, it's a variable that stored the path of the humanity debugger, that is the software that we are going to use in order to debug the process execution and make the exploit. Finally, we don't need it when we have the exploit. We don't need execute the debugger, but during the process it's completely necessary for understand how it's work, the vulnerability. Okay, and what is junk? Junk is the entry. Junk is the entry of the program. For example, hi, hello, execute Python stack streaming. Yeah, execute hi, hello. Init buffer overflow. Yeah, run program. F9 buffer overflow. Yeah, finish. Yeah. Okay, the output of the subprocess call don't write on the. I don't remember how to do that. Subprocess Python subprocess output to variable pipe example output proc stdout read print output. Vale, like that. We can do that, and we can say this is proc is equal to that, and we can say print proc. Okay. Yeah, we execute the program. Yeah, and when finish, say int object stdout. Yeah, clear init overflow. I thought that maybe it's for the debugger. If we yeah, we execute like that, we don't have any problem. Yeah, done. Yeah, done. This is the output of the program. Yeah, the output of the program. Say when finished, say done. Yeah, and this is the done that we found here. Yeah, and on the read. Okay, streaming proc out proc. Yeah, we don't need it. Okay. The execution go fine with a little input, but what happens if we put, for example, 5 or I remember that is, for example, this number of is. We can perform the execution. Don't send init buffer overflow. We can execute the debugger cmd. Debugger cmd. Yep. Yeah. What happened here? We play the program. Okay, the EAIP registry, it's overwriting with 41, 41, 41, 41. 41, if we check the OP codes, OP codes x41, x41, OP code, to us, see, yeah, here, appendix numeric alphanumerical OP codes. Okay, if we follow for 41, inc ACX and ECX, and it's our input A, yeah, A value. If we, for example, change the letter A for B, we found probably 42, 42, 42, 42, 42, because we overwrite the registry. Yeah, we press run. Yeah, of course, 42, 42, 42, 42. Okay, right now we need to find the offset. The offset is the number of the input length that we start to overwrite the input. In order to get the offset, we can use a circular pattern. Yeah. Okay, clear. Yeah, and we can use a tool that is pattern create with a length of 200 of input, and we can inject it inside of junk our input. Yeah. Sorry. Yeah. Okay. Right now. Right now, I'm going to send to the input program a circular pattern that we are going to search before with a Mona plugin. Yeah, find p, yeah, around the whole heap of the memory. Yeah. During the execution, we can check. No, we can't check anything. Okay, and where is the find MSP? Find SP, yeah. This is the output of our command, and say EAP contains a normal pattern in this memory position with an offset of 140 length. Okay, this the meaning of this is that we can inject 140 number of E's and add it B. Okay, in that case we can add it to for example C, and the how many C's? 200 of length minus length of junk. Okay, what is it? The meaning of that is we are going to send A 4 B's B and C. Okay, this is the junk. We can print the junk before send to the debugger. Okay, I'm going to close that and execute again. Yeah, and as you can see here, we send the A and B and C continuously Um, in that case, we should validate that if when we execute we found 42, that is the B42, yeah, the OP code. Um, we validate that the offset, that the next execution of that the next instruction of execute, it's the B instead of another A or instead of another C. Okay, so we can execute that. Yeah, obviously 42, 42, 42, 42. Okay, right now we can evaluate again that and say ESP has a length of 56. This is not a node length, but the offset. Oh, EAX is another register that point to the init of the stack in that moment, and the length for write is 200. It's the registry that we need to found. For the reason we are going to find it. Jump x, yeah. Right now we have another file with the jumps on the register that the functions on the register that jump to EAX. Okay. For example, with one of the instruction, push and read, we can jump to this part of the memory. Streaming, yeah. Right now we can comment that line. This is the next instruction that I want to execute. I can say, for example, with a struct junk is equal to struct path. I'm not sure how that's. Here I can find it. Yeah, struct pact. Struct pact. Struct pact. Yeah. We need to say that right on little endian. Little endian, it's a order that use the CPU processor for understand the memory position. It's to reverse it. The last bytes they are in the previous position, but if we use this library struct, we don't need to change this position. Okay, right now we can copy that, close, reopen and execute again the program. Okay, the entry, no, this is not the entry that I want. Yeah, close the program. There are no bits. Oh, I need save. Oh, CMD. Sorry, CDC. Exercise test 1. Yeah. Python streaming. Yeah. Okay. Yeah. As you can see, this an understanding input is the command that we want to inject in order to jump to the AXP, because in this position, yeah, in this registry that point to the offset 0 in the init of the stack, we have an out length in order to inject our shell code. For this reason, we need put a breakpoint. Yeah. Yeah. Go to expression. Yeah, there is a breakpoint here. If all is right, that I'm not sure that all is right, the process execution should stop in this instruction. When execute the return, we need found all the Cs on the stack that execute after this return. So okay. It seemed that something went wrong. Yeah. Okay. Yeah, X. This is the instruction. Maybe we can check this. Yeah, we can execute again. Go to expression here. Here we can put this and execute. Yeah, right now we are in the breakpoint and execute to the next instruction, execute again, and there are all the C's that we are injected in the CPU. Why I know that there are the C's? Because if we check again the C's, 43 is increment EBX register. This is the increment. Yeah, is X EBX. Yeah. Of course, we can try to inject a new command here. Yeah, without shell code, for example, like this shell code that open a calculator on the operating system. Yeah. Right now, finally, we execute the program. This is waiting. In that case, we inject here the shell code. I'm not sure that if this execution it's go right. Yeah, but this is not right execution, because if we need put the shell code in the init of the entry, for getting out space. No, for this reason we can do that. We can write here that right here. Not okay. No, 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 no. At the init, we need write the shell code. For example, the set code with nopes instructions x x19, yeah, and continuously the number of A's that has the, yeah, minus length of junk. Okay, right now I thought that should be perfectly execute, yeah. Okay, we are going to clean that. Yeah. Finally, the print of junk should be something like that. The inject code, AAAA, the X19, it's a nope instruction. It's for get some space void space. Do nothing. These instructions say do nothing to the processor, do nothing to the processor, and next execute the shell code. It's not needed. We don't need put that. Without work fine, but it's for the debugger. We can show how to jump and execute nothing, and the shell code. Yeah. Again, I need open again. CDC exercise test 1 Python streaming. Yeah. We are going to put the breakpoint. Go to expression. Yeah, to this point. Added the breakpoint. Yeah. Right now it's stopped, and we can go execute the next instruction, and the knobs do nothing, and exec the calculator. Yeah. All right. Right now we can delete the debugger and execute alone the exploit. When we execute that, should open the calculator. Yeah, voila. This is my explain of buffer overflow, stack smashing. Should be better. I could be explaining better, but I thought that there are the minimal knowledge that you have to know for understand and exploit some easy software, because this is very the most easy code that you can find with the vulnerable operation. There are another operation that is string copy A's that allow a max size that solve this problem, because don't allow a bright over the length or the size of my bar content, you know. And with this function, the program is not vulnerable. And this is all. I hope that you learn, that you could understand my English. We speak as soon as possible. See you.